Hi friends, myself Pratyanshu. Today I discuss spherical surface. If I discuss spherical surface, so first I draw a sphere. First I draw a sphere and I cut the sphere through a vertical plane. I cut the sphere through vertical plane AB. If I cut this sphere through vertical plane AB, then two surfaces are obtained. First this and other edge this. If I polished the outer surface of this spherical surface, if I polish the outer surface of this spherical surface, then this is called concave mirror. Then this is called concave mirror. And if I polished inner surface of any spherical surface, then it is called convex mirror. Then it is called convex mirror. In concave mirror, outer surface is polished and reflection takes place through inner surface. And reflection takes place through inner surface. And in case of convex mirror, inner surface is polished and reflection takes place through outer surface. So first question comes in the mind, why I polish this surface? So if I discussed in previous video, at any interface line which divides two medium, if I incident a light ray, then reflection, refraction and absorption all takes place. But now I study only reflection. So to minimize the refraction process, polishing, so I minimize the reflection process. To minimize the refraction, polish takes place. So basically I study about reflection. So to minimize the refraction, polish one surface, and after polishing only reflection takes place. So maximum part of the light it goes back to into the same medium and reflection takes occurs. So first I discuss terminology of spherical mirror, or we can say concave mirror or convex mirror. So first I take a concave mirror and discuss terminology of concave mirror. So basically this is a concave mirror named AB, and as usually you know that the outer surface of concave mirror is polished. Concave mirror is polished. So first thing or first terminology in concave mirror, the geometrical center. Geometrical center of the mirror is called pole. It's called pole and represented by capital P. And represented by capital P. The line joining the pole, first basically, or we can say this is called pole, the geometrical center of concave mirror is called pole. And this concave mirror or this spherical mirror is part of those sphere. It's part of those sphere. So the center of sphere is called center of curvature. center of curvature and represented by capital C. So basically this mirror is the part of that sphere. So the center of sphere is called center of curvature. Now the line joining the pole and center of curvature of mirror, the line joining center of curvature and pole of the mirror is called principal axis. It's called principal axis. Basically, principal axis. The distance between center of curvature and pole is called radius of curvature. It's called radius of curvature and represented by capital R. Now, the initial point of mirror, concave mirror, and final point of concave mirror, the line joining both the point, the line joining initial point of mirror and final point of mirror, or we can say in modified manner, the perpendicular line joining both initial and final point of the mirror is called aperture. It's called aperture and it is represented by capital A. So basically this is the whole terminology of concave mirror. One more important point. If I incident a light ray, which is parallel to the principal axis, if I incident a light ray which is parallel to the principal axis, always goes after reflection through a common point. Always goes after reflection through a common point. That common point is called focus. That common point is called focus and represented by capital F. I again repeat this term. When I incident a light ray on this concave mirror, first thing which is parallel to principal axis, and second thing incident at small angle. If I incident a light ray which is parallel to principal axis and incident at small angle, always goes after reflection through a common point. This common point is called focus of the mirror. And represented by capital F. Now next point, the distance between focus and pole. The distance between focus and pole is called focal length. And represented by capital small f. And represented by small f. This is the whole terminology of any spherical mirror. Either the mirror is concave and convex. This terminology is same. So I think you all are familiar with all terminology of this type of spherical mirror. So I discuss some sign convention of spherical mirror in next page. So now discuss sign convention for a spherical mirror. Because to derive any relevant formula for the reflection by spherical mirror and also refraction by spherical mirror lenses, I used sign convention. because sign convention is an important technique to develop any relevant formula. So basically taken three sign convention. The first sign convention is all distances measured in the direction of incident ray. If I take this is the direction of incident ray, so all distances measured in the direction of incident ray is positive, and the distance measured opposite to the direction of incident ray is taken as negative. It's taken as negative. So the first sign convention rule is all distances measured in direction of incident ray is taken as positive. It's taken as positive, and opposite to the direction of incident ray is negative. Opposite to the direction of incident ray is negative. Second sign convention rule is the perpendicular distance measured above the principal axis is taken as positive, and the perpendicular distance measured below the principal axis is taken as negative. So basically second sign convention, the perpendicular distance measured above the principal axis is taken as positive, and same thing below the principal axis is taken as negative. Now I discuss last sign convention rule is all distance measured from the pole of the mirror. All the distance measured from the pole of the mirror. So basically these three sign convention rule which are applied to any mirror, any concave or convex mirror, or we can say to any spherical mirror, to develop any relevant formula and also any relation between some parameters. Let's say take a question according to sign convention rule and is discussed in next page. Now I take a question. This is a concave mirror. An object O is placed at this place and the image of this object forms at I point. Now in question, find the sign of object distance, image distance, and third, focal length. So first ray coming from the object. So this is the first incident ray. So basically the direction of incident rays from this side to this side. So in the direction of incident ray taken positive, and opposite to the direction of incident ray taken as negative. So first sign object distance. and object distance measured from the pole. So basically this is the object distance. So this distance measured in negative direction. So sign of object distance is negative. Second question, find the sign of image distance. So basically this distance is image distance. If I taken as a pole, so basically this image distance measured in positive direction. So the sign of image distance is positive. Now the third question, what is the sign of focal length? If I form complete sphere by this concave mirror, so basically this is the center of curvature and this is the focus point, and the distance between focus and pole is called focal length. So you observe that focal length is also measured in negative direction. So the answer of third question is the sign convention of focal length is negative for any concave mirror. So I find these three questions by use of sign convention for any spherical mirror. So I hope you understand what is the sign convention for any spherical mirror and how I use sign convention for spherical mirror, and also familiar with the terminology of spherical mirror. If you have any problem, then comment me on the comment section of this video. So please download the Scholar Learning app, and if you already download this, then enjoy learning. Thanks to watching this video.